Hello, welcome to lesson 3 of simultaneous equations. Today we're going to look at solving pairs of equations by elimination. Our first thing we're going to do though, as per usual, is a starter. So if you pause the video for a minute or two and complete these questions into your class jotter, please. Okay, let's have a look at the questions. So when we're doing these questions, we need to remember our rules with signs. So if we want to add a negative, remember that's just the same as subtract. If we want to subtract a negative, that's the same as add. When we're multiplying a positive with a negative, overall we get a negative. And when we're multiplying a negative with a negative, overall we get a positive. Let's look at A. Nice and simple and straightforward. 2A plus A is equal to 3A. For B, we've got 5C add negative 2C. Adding a negative is just the same as subtracting, so we get 5C, take away 2C, so we end up with a total of 3C. We've got 3B, take away 5B. 3 take away 5 is negative 2, so 3B, take away 5B is negative 2B. If we look at D, we've got negative 3B, add negative 5B. So firstly, we'll simplify this to negative 3B, subtract 5B. So negative 3, take away another 5 is negative 8. So overall, we have negative 8B. Now some multiplying examples. 2 times 4A is simply 8A. 5C times minus 6. 5 times minus 6 is minus 30, so 5C times minus 6 is minus 30C. For G, we have negative 4 times negative 3B. Negative 4 times negative 3 is positive 12, so our answer here is positive 12B. Okay, let's look at today's lesson. So today, as I said, we're solving simultaneous equations by elimination. By the end of the lesson, we want to be able to understand the elimination method for solving pairs of equations and be able to use this method to find the solution or point of intersection of the pair of equations. Okay, let's have a look. First of all, some definitions. So eliminate means to get rid of. Variables, that just means the letters used in an equation or expression. Now the elimination method that we use is when we solve the pair of equations by getting rid of one of the variables. Elimination is an algebraic method, so we do not have to draw any graphs, so you'll be quite pleased about that. A couple of things we need to remember before you begin. That both equations must be in the form ax plus by equals c. So an a term plus or minus a b term equal to a c term. When deciding which variable, that's which letter to eliminate, we look for, now this is very important, this is the key to doing this method. So look for the same amount of x or the same amount of y in both equations, but with opposite signs. So the reason we do this is what actually creates the elimination, because the two terms then cancel each other out. So let's look at an example. So here it says use elimination to solve the pair of equations 2x minus y equals 6 and x plus y equals 9. So the first thing we do is copy the pair of equations down and label the equations 1 and 2. The next thing we've got to do is decide which variable, either x or y, we're going to eliminate. So we're looking for the same amount of x or the same amount of y in both equations, but with opposite signs. So if we look at equation 1 and equation 2, we can see we've got negative 1y in equation 1 and positive 1y in equation 2. So in this case, we are going to eliminate y. We do this by adding both equations together. Now when we do this, the y terms will eliminate and we are left with a total of 2x plus x, which is 3x, equal to 6 plus 9, which is 15. We now solve the remaining equation. So the simple equation 3x equals 15, we divide by 3, and that tells us that x equals 5. So now we have the x coordinate of the solution. We now need to find the y coordinate of the solution. So what we do now is we substitute x equals to 5 into either equation 1 or equation 2. This is for you to decide. You just choose which one looks easiest to use. So I'm going to use equation 2. So replace the x with 5, and we get 5 plus y equals 9. And all we need to do now is solve that simple equation again. So take the 5 over, y would be 9 take away 5, so y is equal to 4. Now we have the y coordinate. But remember, from the graphical method, this represents a coordinate point, a point of intersection. So we should always state the solution as a coordinate. And remember, the x value is always first, and then the y value second. So if we had plotted these lines and drawn them, we would have found the point of intersection at the coordinate 5, 4. The last thing we need to do is check that our solution is correct. So what we do is we take the x value 5 and the y value 4 of the solution and put these numbers into both equation 1 and equation 2 and check they are equal to the right hand side of the equations. So for equation 1, when we put the values in, we want to check that we get 6 out, and we do. And for equation 2, when we put the values in, we want to check that we get 9 out, and we do. So we know that the solution 5, 4 is correct. Let's look at a second example. So here we've been asked to find the solution to the pair of equations by elimination, and we've been given 2y plus 3x equals 13, but the second equation is written slightly differently. 5y equals 3x plus 1. Remember we said before you begin that both equations must be in the form ax plus by equals c. So what we have to do here is rearrange the second equation. So we move the 3x over. Remember, 3x will become negative 3x, so we will end up with the equation 5y subtract 3x equals 1. So let's apply this and solve the pair of equations. So firstly, rearrange the equation. So the pair of equations is now in the right form, and we can begin to follow the method shown previously. It's exactly the same as what we've already done. So firstly, label the equations. Second thing, decide which variable we are going to eliminate. So we're looking for the same amount of x or y, but with opposite signs. So we can see in equation 1 we have a plus 3x, and equation 2 we have a minus 3x. So we're going to eliminate the x's. We do this by adding both the equations together. So when we do this, the x terms will eliminate. We total the y terms and total the numbers. So we get 7y equals 14. The next step, we solve the remaining equation. So if 7y equals 14, we divide by 7, so y will equal 2. Now notice here we've eliminated x first and got the y value. It doesn't matter which way around you do this, it just depends on the equations that you've been given. Step 4, we're going to substitute y equals 2 into either equation 1 or equation 2. Again, remember, it's just whichever one you think looks easiest. I'm going to use equation 1. So replace y with 2. So we get 2 times 2 plus 3x equals 13. So 2 times 2 is 4, so take that over, and becomes 13 take away 4, so 3x equals 9. Divide by 3, so x is equal to 3 this time. So remember, we need to write our solution as a coordinate point, but remember it's always the x coordinate first, then the y coordinate. If the letters in the equations are different, say for example it could be G and H, S and T, just put them in alphabetical order. Lastly, check our answers. So put x equal to 3 and y equal to 2 into equation 1 and 2 and check that we get 13 and 1 as our answer. So for equation 1, we get 2 times 2 plus 3 times 3, so that's 4 plus 9, which is 13. And for equation 2, we get 5 times 2, take away 3 times 3, so that's 10 take away 9, which is 1, which is exactly what we are looking for. So therefore we know the solution 3, 2 is correct. Okay, now it's over to you. Please go to posts or files on the team to get today's exercise and answers. Complete the questions into your class jotter. Remember to make sure you show all your working, and then check and correct your answers at the end. Thanks.